Hi, so this is our last video for Lecture 2, Week 2. I'm going to talk here about Assignment 2 and then answer some of the questions I've gotten with respect to some of the reading process. So in doing this, please make sure you go in and you enter this under Assignment 2, not in your journal. You are still to do a journal this week, but the journal you're doing is about your learning, your insights, and questions, and I want to separate that from the content of what you're going to do for this assignment. So last week you did a search. This week you're going to do a browse. I want you to choose a top journal or conference, probably the one you identified last week, with more than 30 papers from one of its 2016, 2017 issues. And you're not allowed to use anything before 2016. So this has to be very recent stuff. I want you to get some experience going through that. You are not to search for papers with keywords. You can search for journals or conference titles, but I want you to do an entire issue or at least 30 papers from an issue. And in that issue, you are to browse at least 30 papers. It may be more because you might not find all of them relevant. So if there's a conference with 100 papers, browse at least 30 of them, and you can skip others just by a title. I want you to time yourself on each. Aim for no more than 2 minutes in your browse for a paper to decide is it relevant or not. Then you are going to scan at least 6 of those papers, and for each of those, write a 2 to 3 sentence summary. For the 30 papers, I want the bibliographic list of them in a proper bibliographic format. It's okay if it's BibTeX or MLA, whatever format you want. I don't really care what that looks like. But in your uploaded file, I want you to have the 30 papers as proper references. The 6 that you scan, I want those as both references, and then the 2 to 3 sentence summary of those 6 plus. Then I want you to critically and creatively read the best 2 or 3 of those papers and upload your notes. That should, if you want to take notes on hand, that's okay. You can take pictures with your phone of your stuff. I just want to see that you've done the work. I'm not worried about it all being computerized. If you don't, that's not the way you approach stuff. Okay, so 30 papers in the browse, full bibliographic information. Normally when you're doing a browse, you don't keep the bibliographic information, but I want you to go through that process this time. So I want the titles, authors, all the things you'd have in a normal bibliography. Scan of 6 papers with a 2 to 3 sentence summary of what's the paper and your determination. Should you go forward and read it, why or why not? And then critically read 2 or 3 of the best of those. And all the notes for all of that stuff will go on Assignment 2, which will be posted on Blackboard later today. In class next week, I want you to be ready to discuss your process, your insights, and your learning from this. Not necessarily the paper contents. I don't want to hear summaries of the papers. You wrote those in the 2 or 3 sentences, and with 15 students each doing a different topic, it'll be very confusing if we get too deep into those. So now I'm going to answer some of the questions I've gotten about sort of the reading and the browsing processes. In the journal, after some observations, sort of the question was, how does one find new high-quality conferences, and to what extent can one even tell if they are high quality going from a search? So nothing in Google Scholar metrics could really help find that. So if you're looking at something that is the first conference of its kind in 2016, it's not going to have a Google Scholar metric. You might not find much about it. This is especially true in new technology like computer science. This question seems very pertinent. This is an important question, and it is very hard. When you look at a new conference, the only way I know of to really decide how good it is a combination of who's the publisher, and because publishers that are more serious, like IEEE, if it's really an IEEE sponsored conference, there's a process that has to go through to get to be published, but that alone is not good enough. And there probably are some good things that didn't go through it, like International Conference on Learning Representations, ICLR, is a decent conference, and it does not have a normal publisher. The second, and maybe the better way, is to look at the organizers. Conferences will have a general chair. They will have a program chairs. Look at those people, take those names and stick them into Google Scholar. And if the people in charge are very reputable people where they have their own Google Scholar page with thousands of citations, then it's probably aiming to be a pretty good conference. If when you look these people up, they don't have much of a reputation, might not be a good conference. I'm not saying it won't be, it just might not be, but you might want to let time play out and figure out from that passage of time, is it a good conference? But if you're in a niche area and it's the most relevant thing you can have, take a shot, read some papers, and then you'll start to figure out how good it is. It's not quite as risky as where do you submit your paper to decide where you're going to read. So reading is not too expensive. Give it a shot if you're not sure. So if your reading list keeps growing and you're falling behind, how do you prove? Well, hopefully your reading list hasn't grown that fast, that far, that you're in that much of a shape. I actually don't view this as pruning. I view it as prioritizing. So in fact, in my reading list, I tend to have things in 3 categories: things that I absolutely have to read. It doesn't matter. I will have to find the time, and sometimes those are, I have to find the time in the next week to read them because they are so critical for a paper we're working on or some research we're doing or proposal that's going to happen. Category 2 are things that I feel I absolutely have to read, but they don't have a time deadline. So I will try and find time sometime in the future. And then I have this really big list of stuff that is, this would be nice to read. To get on those lists, I've already done the scan. Nothing gets on those lists for me to come back to later unless it's gone through the scan. So when I do the browse, I start scanning papers, they can end up in that list. The answer to how do I prune them? Well, pretty much every day I get up and figure out what things that are on my list of things to do will never, ever happen because I have more work to do than I have time. And that includes lots of those papers on the list. Sometimes I let time help me in the sense that if after 6 months, I also go back before I reread them, and this is important if you've been on your list for that long, and I have plenty that have been that long or longer, I go back and check, has anyone cited them in the last 5 or 6 months? And if not, maybe that's a reason to just prune it off my list because it's not getting any attention. And then sometimes other things will overcome it, and there'll be a newer paper, and then I won't read the older one unless I really feel I need to. So I will often do something somewhere between the sort of scan level, which is maybe a 5 to 10 minute read of a paper, and a deep read, which might be a couple hours. I might do a softer review where I'll go through the paper in half an hour to an hour and consider that my read, because it's somewhere in between. I've read it, but I'm not going to take time to dig really deeply because I'm falling behind. So it's a good question and hard to do. You'll deal with that a lot. One student noticed that they choose some papers, or they might choose some papers based on having less equations than others, or almost none. Which, yeah, it's really kind of an issue. It doesn't mean it's not interesting, and so how can you change your behavior with respect to that? So if you notice yourself having these kind of bad tendencies to not want to read it because it has equations, let me first comment that in the read, until you get to the deepest of reads, you might not have to really get deeply into the equations. You should be able to figure out what the paper is doing without the equations, and going the other way around. If the context gives you enough understanding, you will be able to look at that equation and say, oh, well, based on their paper's description of them, you know what they mean, because they told you in words probably as well. And that can actually help you understand the equations and become more comfortable with them. So if you can't follow all the equations, view them as weird-looking pictures that you can associate with the caption, the text, and that'll give you a feeling for them. Don't avoid them. In fact, in general, when I have a fear, I recommend you face those fears. So read more papers with equations, and you'll become more and more comfortable with them, even when you don't really deeply understand all the equations. Now, is that the best thing to do? No. Eventually, you really face the fears. You dig into those equations. But you'd be surprised how reading half a dozen papers that use the same equation and put it in context will give you a pretty good feeling for what's going on, even if you couldn't derive that equation. That's much harder. The ability to make those equations come up. Very often, papers are written in a form where the authors make it seem like, here's the steps we went through, and it seems like you could never do it that way. Well, I have some important information for you. Very few papers are actually done that way. There are people who definitely think equations first and whatever, but very often people have had some insight, they do some implementation, they do some experimentation, and then they write the equations to explain what's going on. And sometimes they do the equations and then they iterate many, many times. But the final form you see it in is not how things are generally done. The research process isn't the same as what you read in a paper. In fact, papers are often written to make the author seem clever, even though it might have taken them a long time in a very backward way of getting there. It's a little bit like reading proofs in calculus, but that's not how calculus was derived or used. It's just how they present it. So don't worry if that you don't see how they could get there. That's another process you'll go through later. Some research, the design covers large-scale implementations. However, during the actual experimentation section, a smaller scale implementation is applied. Doesn't this affect the final results and usability of the proposed solution? Absolutely. Yes, it does. If they're describing a large system and then they test it in a small setting, what they really have done is they tried to motivate you by talking about large scale in big problems, but then they try and hopefully they just try and prove a smaller element, smaller part of what they're doing by doing this small scale experimentation. But that's up to you during the critical read to decide, does that small scale implementation really reflect the hypotheses that they were trying to test in the larger scale solution? If they're trying to talk about how something scales and they only tested it on 15 pieces of data, they've not answered a scaling question. But if they're trying to show you that it works in terms of finding a minima and they've tested it on 15 problems of size 15, but they've done dozens of such small problems, that might actually be a pretty good indication of what's going on, even though they argued about large scale. And if they've actually shown by a small scale something that works on maybe hundreds or thousands, and they're talking about tens of thousands, a factor of 10, they can probably get some things on. But very often, the first thing is motivation. The second experiments allow you to be much more narrow, and then you have to decide how much does that matter to you. In the state-of-the-art or background sections of some papers, they don't really cover what's implemented in industry. And if there's this big gap, what should you do about it? And if so, how can we find our references? Can we use white papers or information from our industry? For those of you who are in the PhD in security program, this is sometimes more of a problem. There's often a big gap between what industry is doing and what academia is doing. But it actually goes both ways. There'll be plenty of papers in industry that claim things but have no experimentation and no theory and no science to show that they're true. And then there'll be academic papers that don't compare to industry, but sometimes those experiments are impractical. So you can talk about white papers or information provided by industry, especially for motivation of what's in the problem. But if you can't compare against it, and you'll find this when you try and go to get their code, we've had plenty of times where we get licenses from companies for their version, but as part of that, the license say we can't publish their performance. So they restrict you in what you can do, so that you can't talk about the limitations of their work. So it's a problem. It's a problem in some areas much more than others. You should take that into consideration, both when you're reading papers, because sometimes they really are far behind the industry state of the art. And it's one thing if a paper discusses it and says why they can't. It's others if they just ignore industry. So that's up to you to make a conclusion in terms of your critical analysis, what that's doing. When you're choosing your own research area, though, that's also important. If you keep seeing papers in the area you find interesting and they're not comparing against industry, you should be really asking yourself why, or maybe write to the authors and ask them why they didn't. That's another good example of, well, you might help the authors by pointing out, it's like, well, why didn't you guys compare against this? See what their answer is, and maybe the answer is because they didn't know about it. Not great, but at least you'll be helping them along as they help you. So if you're doing this and you're browsing, they're laden with vocabulary or subjects with which you're not familiar. You can't even really understand the subject of the paper without doing additional digging, looking up terms. So if you're looking for something that's looking for symbolic execution framework for Java, right, what is that? Right? Well, so this is your research area. You're getting to be a PhD student. Doing a little bit of looking those things up is okay. Even if it's not your area, if that paper showed up in a conference where you think your work could show up, you should be able to understand those terms. You might not be able to do the research or really understand it, but basic understanding of those terms is good. So my recommendation is, while you're reading the paper, if you're not sure what it is, write it down. You might decide that paper isn't relevant because you don't know what it is, but I recommend before you make that decision, you look at the figures and some other things, just because there's a couple of words you don't understand. Some people like to sort of show off their prowess of vocabulary and use words. Other times, they literally make up words. I do all the time, because you're trying to make your work distinctive. And if you are the first one to coin a term in its usage, then people will refer to your work in that way, and that can be helpful. So don't be too embarrassed that you don't know those terms. Go look them up and doing it. If you find yourself like wanting to go read an entire other paper just to understand this paper you're browsing, you've definitely gone too deep. If you're doing a deep read and you have to go read another paper, well, that might be acceptable. In general, however, I don't recommend a depth-first search process where you get to something you understand and you go try and read it, and you run into something else you don't understand, you go try and read that. My recommendation is more of a breadth-first search or a best-first search, where you're understanding the paper, where you say, okay, I don't know exactly what that is. I will just come back to that later. Maybe by reading the paper I'll understand it. If not, after I'm done, I will go deal with that. Because it's just a term. View it as some term you don't know what it is. After you've done the paper, you can go read about what it is. As a subject matter expert for the field of digitization, what are the expectations of knowing the algorithms? There really are hundreds of them. For example, machine learning, how can one have them all memorized? In the past, people have built domain knowledge, but that can take years. So you don't have to have them all memorized. I couldn't name all the algorithms that I had on that machine learning diagram. I'm not sure I could name them all, but when I read them, I can then recognize them, which is very different than having them all memorized. You should be able to have by understanding the taxonomy of where they are and what they are. But it does take years to build domain knowledge, and the broader the field, the more that's going to take. So your expectations of knowing all the algorithms, the details of them, the closer they are to your research work, the more you have to know about them. The farther away they are, you have to be able to recognize them and have some understanding of them. So yes, it may take you years. This is only one class, but being able to have a decent lexicon, vocabulary of what they are and knowing where to look them up, that's important as well. While doing research, collecting papers, is there an environment that supports this? How do you do change tracking for annotations and tracking insights and understanding from papers and bring them all together? Are there other research tools besides the ones you listed? So I've already mentioned some of these in class today, because this is in the videos today, because that's a common question. So I talked a little bit about Zotero. Zotero is a pretty good tool. It'll allow you to both track your citations. So when you're doing your browse this week, you might want to use Zotero so that you can import your bibliographic things to make it easier to turn them in, if nothing else. But keeping that bibliography and putting comments in it is useful. Because you can actually add comments, you can update your understanding of those papers over time. You can, like I do, be very old-fashioned. I use flat text files in a text editor and grep to keep my notes. That's a perfectly fine way of doing it as well. I use a combination, because BibTeX files are flat text. They're structured text as well, but you can have a notes section where you put your own notes in there, and an abstract section where there's an abstracted paper. You can do a bunch of stuff with that. Whatever tool you want to find, but those are the two I recommend, whatever your favorite editor is, and Zotero. And obviously, as I mentioned last class in the last week's videos, I'm using the My Library function within Google Scholar. With respect to some other tools, there are two others I do recommend. One is my favorite dictionary. It's called onelook.com. And I use this dictionary. It's my primary dictionary of any kind for two reasons. First of all, it's a dictionary. If you put in a word, like as it says here, bluebird, it'll tell you what a bluebird is. If you're not quite sure how to spell bluebird, I could probably spell it, but maybe I would have struggled. I could actually say blue star, and it'll find all the words or phrases that start with the word blue or star bird. Right? It's almost regular expressions. You can literally have the question mark operator and find out things that have, if I knew the word was blizzard and there's BL something RD at the end, right, or BI, right? You can put in some things and it'll tell you all these words. So for somebody who can't spell like me, for whom dyslexia makes it really hard, I'll know the word starts with a B and ends with an RD and not sure what else is in it. I can find that word. All that's great, but what makes it more important and more useful when you're trying to do your research is it actually has this idea of a reverse dictionary. So I can say something like BI star : snow, which means tell me all the words that start with a BI and have something to do with snow. And it'll actually sort them on relevance related to its answer. In fact, I don't even have to know what it starts with. I can say : winter sports. So if I put in a phrase from a research paper and I say : star : and then that phrase, it'll give me some ideas or related words that will help me understand what's going on. And then you can ask for phrases that contain words, again, using the star operator. It'll even do some interesting things with respect to expanding. It has a great thesaurus, so if I'm looking for things related to a particular word, I can use the star : approach, or I can click on thesaurus or use the reverse dictionary. So I find this a really nice tool because it helps me in ways connecting words. The other tool I do recommend, and I'm going to put it out there now, we'll talk about it again when we do writing, is this tool called Grammarly. It'll help you find errors in your grammar. Although there's a free extension for Chrome, there's a limit to how much you can search for free. It's like $90 or $100 a year to have it check your grammar or whatever. I use it multiple times per week, probably on every paper multiple times. So it's another tool worth doing. It's not going to help you find stuff, but it'll help you fix grammar if you struggle with that as well. Another question, what are the methods for down selecting topics that exist in the same space? And if that topic can take both a qualitative and a quantitative research approach, what are the decision factors? So this one's a little out of context. It's not quite sure. There's two parts to this. So down selecting topics, in my view, is if you're doing your browse and you're trying to decide what topics are of interest to you, the most important thing is what's of interest, but if you don't have a broad enough perspective, that's not possible. for you to always make a good decision on that. So a different way of thinking about down selecting is, where will I find an impact? So there's another related technique. While you're doing your browse, if you're looking for what are hot topics and you read last year's conference proceedings, you can literally take some of those keywords that are of interest to you when you're sort of thinking about what those topics are, and you can count how many papers are in each topic and get a feel for how hot is that. Many conferences, CVPR, the field in which I work, we tend to actually publish in the sort of notes from the program chairs that go along with the paper. In that, we'll publish the selectivity rating, but they'll often talk about the number of papers that were selected for each topic area. There's advantages to working in the hot topic because lots of people are in that. It's exciting when you go look for a job. People are very excited about that topic, at least if it's still hot. There could be a lot more citations in that area because there'll be more papers, there'll be more citations. The disadvantage is you'll be competing with a lot more people. So if you're going to be working full-time on your thesis and you feel you can keep ahead of the people at Columbia and MIT and Berkeley that are working in a hot topic, take them on, go ahead, go for it. If you're working part-time, it is much harder for you to keep up with and stay ahead of somebody who is going full-time at another school. So then you might want to choose topics that are a little bit more on the side because you'll have less competition and less chance of getting scooped. So that's a high-level decision factor. Whether or not you want to work on things that are qualitative or quantitative, as a computer scientist, you will do some quantitative research analysis. There's almost nothing you can do in CS that is pure qualitative. But in terms of the balance, if you like qualitative stuff, you can go down that path. So if you're doing HCI, there can definitely be some qualitative things you want to do. And those decision factors are normally more a function of what you enjoy and what you like. But be careful to make that decision until you've gone a little bit farther down that path. And related to this, when you're sort of looking at fads and lasting ideas, it has a thin boundary. How do you differentiate between two at the early stage? Some ideas, like what might become as fads, such as deep learning as a concept, but now it seems to be a lasting idea. How do you know that until it's been proven? Well, deep learning is a great example because when it first came out, I wasn't excited about it at all. Deep learning or neural networks have been around for a very long time, and I've seen what seemed to be a fad come and go. Part of what made me decide to get into deep learning this time was not just that it was there, but that the performance was so much better than the state of the art. And not just in one problem. When the first papers came out, it was much better in one problem. And I think, oh, well, that could just be something special about the problem and or the data set. There's lots of reasons to do that. But after it became the state of the art in three very different problems, I said, I can't be ignoring it now. So I missed the boat a little bit. I could have been in the deep learning phase 2 years earlier. But there's a balance in terms of doing that. So how do you make the decision? Fortunately, I can't answer this question. You make the decision based on your own gut feel and what you like to do. And in my case, part of the answer was also I had to get funding to be able to spend a lot of time and have my students spending time on it because I have to fund the students to get the work done. So fads versus lasting ideas, look at who's doing the work. So part of what also got me into it this time is the people who are doing deep learning weren't just people I'd never heard of publishing in areas that I don't really look at. These were now big names from top universities who have dozens or hundreds of papers doing work and publishing it at the top venues, in which case you can no longer ignore it. So that's it. So for this week, going back to the assignment, you're doing the scan of, you're doing the browse of at least 30 papers from 2016. Time yourself, aim for no more than 2 minutes analyzing each of those 30 papers to decide is it worth doing the next stage on. The scan, you're going to spend 10 to 15 minutes on each of those 6 papers and write a 2 to 3 sentence summary. It can be 5 minutes if you're quick at scanning. Don't write the 2 to 3 sentence summary by just looking at the abstract and taking 2 or 3 words. I want you to really look through the paper, get a pretty good feel for it, and then critically and creatively read the best 2 or 3, which means you're probably writing a page or 2 for each of those in terms of what you're going to get out of it. And really spend some time on reading it creatively. In week 1, a number of the students who did turn in Assignment 1 were a little light on the creative side. It's easier to be critical, as I said, than to be creative. Finally, please upload this as Assignment 2. You have 2 things you're going to upload, Assignment 2 and your journal. Those are separate things. In your journal, you're going to be talking your processes and insights, but all of this material goes in Assignment 2 on Blackboard. So it's a little bit short in terms of the videos this week, but you have a lot of reading to do, so I don't want to record extra material. See you in class next week.